I've heard you say that you think Parkinson's disease starts in the gut, as inflammation in the gut.
Yeah, that's a great example of how my view of these diseases is changing. There's really good epidemiology data now.
What's epidemiology data?
Epidemiology data is data in large populations. So you study the cause of disease by studying populations. That's essentially what epidemiology is. And what these studies have shown is that if you follow susceptible people and find out who at the end ended up with Parkinson's disease, you will see that about 90% of people who end up with Parkinson's disease had some gut problems 10 years before. And you might say, okay, well, might not be related, might be two separate things, but they've actually found the same protein changes in the brains of people with Parkinson's disease, this particular protein that gets misfolded. It's a bit equivalent to Alzheimer's, but it's a separate type of protein, alpha-synuclein, and it gets folded and you get this characteristic thing you can see post-mortem called a Lewy body. But it's the protein folding that's important. And if you look in the gut, not only do these people have constipation and bloating and problems 10 years before, a really sluggish intestine, but they have the same proteins that are misfolded that you can find in their gut. And they think that it takes 10 years for these proteins to go slowly up the vagus nerve into the brain, and then it causes the problem there. So this is the latest theory behind Parkinson's disease, that it actually starts in the gut, and it's related to inflammation in the gut. So these proteins start folding when the gut is not happy, which means that you could potentially prevent Parkinson's disease by a gut-friendly diet. It looks like the evidence is building that that's going to be pretty concrete soon. If that's true, then you may think, what other diseases might have that origin there that we really don't understand? What about multiple sclerosis that might happen there first? And it really starts to bring this obscure these brain disease back into the domain of the rest of the body and what's going on there and these metabolic problems. Diabetes is the number one risk factor for so many of these conditions as well. So if you've got type 2 diabetes, you're like 4 times as likely to have a brain disease. Not only depression, but also bipolar, schizophrenia, epilepsy, all of these ones. So clearly they're linked. They're what goes on in your body, what you're eating, what your immune system is doing has this amazing knock-on effect.
So what do we do about it? What does the average person do about it? Because what the average diet looks like in the Western world. If we want to have optimally healthy brains and avoid dementia, Parkinson's, and some of these other disorders that are linked to the gut, what is the most important thing the listener right now should be thinking about and doing?
Well, I like to think I've got a list that's getting longer, but I've got 8 rules for gut health, which pretty much work for all health, because to treat the brain, it's no really different to treating the rest of your body. If you treat that well, you're going to be fine. So the first thing is to be mindful of what you're eating. Don't just put any old shit in your mouth, Stop for a bit and say, what's in it? Is it any good for me? How's it going to make me feel?
You mean checking labels and stuff?
Checking labels, or even just taking a second to think, gosh, don't just blindly eat in front of the TV without thinking what you're eating, as most of us do. Second, and probably the key thing is to eat a diversity of plants, 30 plants a week. These 30 plants give you the diversity of chemicals to act as fertilizers for getting as many good bugs as you can into your system.
How can you explain that to someone that doesn't know much about the gut?
When I'm talking about your gut, I'm talking about gut microbes. And there are 40 to 100 trillion of these guys mainly in your large intestine, that are mini pharmacies. And we have thousands of different species, all of which highly selected to eat only certain foods. There's one that only likes coffee, for example, called Lawsonobacter.
A bug that only likes coffee in my belly.
It's just waiting for you to drink coffee.
And when I drink coffee, what happens?
It has a party, has sex, has babies, multiplies, and then produces certain chemicals in response by breaking down that coffee into other ingredients, which might then help your immune system and in some way explain why coffee is good for your heart. So you've got to imagine that you've got lots of bugs like that are highly specific, waiting for you to have not only coffee, but maybe it's seaweed, or maybe it's baobab, or maybe it's things you don't often have, so that we can expand our list of good bugs.
So if I stop eating a particular food, like coffee, if I stop having coffee, will that bug die?
It probably goes down to very low levels, because actually what's interesting is even if you stop drinking coffee, you're surrounded by coffee drinkers. And they're droplets of saliva and kisses and greetings mean that you'll be getting some of that, either those bugs themselves, or you'll be getting some bits of coffee in the air, a coffee aroma.
Okay, so the bugs go up and down in population.
Yes. So even in non-coffee drinkers, we do see tiny amounts of this Lawsonobacter. But in countries that don't drink coffee at all, there are a few African countries, for example, where it doesn't exist. In tribes, you don't see it at all. But I think it's important to imagine it's a bit like having a rare animal. You've got to feed in your zoo. You don't want to give them all the same food. You've got to give them this diversity so that all the rare animals can get out there. And we know that the more good bugs you've got, the better your immune system, the more you dampen inflammation, the more you can prevent all these problems that we're seeing. So our aim is to build up the good bugs, and the more you build them up, they squash out the bad bugs, the ones that like eating the burgers and the bad food and the terrible quality fats and the artificial substances. So you're squashing them out by starving them, and you do that by feeding them properly. So that's the concept, if that makes sense.
And on that point of coffee, doesn't it restrict blood flow to your brain?
No, not as far as I know.
Oh, really?
I know about coffee at the epidemiological level, so there have been multiple studies, like I was saying, in coffee drinkers, non-coffee drinkers, seeing what happens to them 20, 30 years later. And drinking between 2 and 5 cups of coffee reduces your risk of heart disease by about 25%. So there may be other studies showing it does something to your brain, but generally everything I've seen is beneficial. I've not seen anything negative, although there are some people who react to caffeine badly. So there's always a personalized element to it.
Sleep disruption and stuff.
Yes. So you might be a metabolizer. It doesn't metabolize quickly in you, so that caffeine is hanging around longer. So they're the only downsides to it for some people.
Can it make you more anxious?
I think it can make some people more anxious, yes. And that's why things like matcha are better than coffee, because they have an extra chemical in there that can calm you down. So like anything, any food, it's all personalized. And so when we talk about epidemiology, we're talking about the average person. Doesn't mean there aren't exceptions. So I'm not saying that everybody in the world needs to have coffee, but coffee used to be demonized as something that would give you heart attacks and arrhythmias. And in fact, the opposite is true. Epidemiologically speaking, you get less heart abnormalities, arrhythmias, when you drink coffee, for reasons we still don't understand.
So the first point of the 8 was being mindful about what you eat.
Second was eat 30 different plants, and that was the basis of our Zoe product, the Daily 30, which has 34 mainly freeze-dried whole plants in it. And we've recently added some more. So we added some seaweed, some algae, and some kombucha in there. So they're rare ingredients. We've got 7 different types of mushroom that you wouldn't normally have.
It's worth me saying that I'm an investor in Zoe. And let me take a look. So you take this out and you sprinkle it on top of your food typically.
Yes, you add it to food, and it's different to most of the other sort of supplements you might see. It's not instead of food. It looks more like food than most of the common supplements out there that look like green powders. We did a big trial of this with about 340 people, comparing it to a probiotic and a dummy one. And over 6 weeks, you get really quite dramatic improvements in your gut microbes with eating this. So you really push up the good bugs and squash out the bad bugs about several times more than you would get just by having a traditional probiotic. So this fertilizer approach does seem to work. And this is the study where we also showed the improvements in mood after a few days, which surprised me because I wasn't even thinking about that when we planned the study.
So the key reported findings in that study were a gut microbiome improvement, an average increase of 5 points in their Zoe gut microbiome score. Digestive system, 70% of people reported improvements in overall digestive systems symptoms. And it increased fullness by 41.5%, satisfaction by 21.6%, and energy by 43.3%, and reduced hunger and desire to eat versus the meal alone. About half reported increased energy and 45% reported improved happiness in the main study.
So we weren't expecting that. That was my point really on these, because we thought it would just be gut. It would like, okay, do I go to the toilet more often? Is it improving my gut microbes? And so it was a real bonus to see these brain effects.
And did you do stool tests on those people to see
yes.
the change in the bugs in their stomach over that period? Was it 6 weeks?
It was around 6 weeks, yes.
Yeah. And what did you see change in their gut bugs?
So we've got a new scoring method for gut bugs, which we published last month in Nature. And so we used to talk about diversity. And on previous podcasts, I think we've talked about diversity, which is the number of different species. But we've got a better way of looking at that now, which is to take 100 most important bugs that change with diet that everybody's got, because we're all different. It's very hard to compare your bugs with my bugs because we'll only share 20%. So this looks at 100 common bugs that we've both got, 50 good and 50 bad. And what we want in an intervention is to see the good bugs that are associated with good diet and good health outcomes, good blood tests, are going up, and the bad bugs associated with inflammation, poor diets, and bad health outcomes are going down. And that's exactly what we saw. We saw a change in roughly 40 of these microbes with the prebiotic, the Daily 30. Whereas with the probiotic, which we know works from other studies, we saw only a change in about 4 or 5 of the bugs.
Okay.
So they both worked, but the prebiotic was working better than the probiotic, which has sort of changed my mind about what's more powerful.
So prebiotic being what and probiotic being what?
Prebiotic is like a fertilizer for gut microbes. It's giving them food.
Yeah.
So that, and in an indiscriminate way, because we're giving a wide variety of foods. In these 34 plants, each of them has hundreds of chemicals. So there's thousands of different things for them to feed on. Whereas a probiotic, we used Lactobacillus rhamnosus, which is a well-known one that's been studied in hundreds of trials. It's a live microbe that lives generally in foods like yogurt and things like this. In a concentrated form in a capsule, you give that, and it improved the gut microbiome, but much less than the.
So prebiotic gives them food. Probiotic actually just puts bugs in there.
It put bugs in there, and we used to think it was like a seed. So fertilizers and maybe seeds, but we now know that bug will never really seed in your gut microbiome, and so the science and our thinking has changed. We think the probiotic is really tickling your immune system as it's going down.
Okay.
So it's probably working higher up in the small intestine, which is further up in the gut.
Where is the gut?
Yeah, so most people, if you ask people to point to the gut, they always think of their stomach.
Here.
Yeah, well, that's not your stomach, you see. They're the intestines. So your stomach is up here. I'm going to take away your liver. If you imagine we've got a body here, a mouth, food goes in there through the esophagus, which is a tube that leads to the stomach. And this is the stomach here, which is highly acidic. And that leads into the duodenum through a little valve. And that is where food starts getting mushed around into little balls. And it goes into the small intestine here, which is badly named because the small intestine is really the largest bit of the gut. And it's endless coils of guts. There are lots of crypts. There's little nooks and crannies everywhere. And so the surface area is really huge. It's several tennis courts if you laid it out, just one in one human. And that's because that's where most of the nutrients get absorbed. They get extracted from the food and absorbed that way so that all the trace elements and things we're recycling. We're like a recycling factory. And then from the small intestine, it then goes into the large intestine, which is also called the colon. And that's where most of the gut microbes are. So 99% of the gut microbes are in that final part, the large intestine, which is a couple of meters long and varies widely between people. And this is the spot where fiber goes, things that hasn't been digested in the early part of the gut, and that's because the microbes mainly feed off fiber. And so that's where they do the good. They convert that fiber into products such as short-chain fatty acids, which are the really beneficial chemicals that are good for our immune system. And it's important to realize that across both the small and the large intestine, you've got huge amounts of nerves. You've got what's called the enteric nervous system, which is our second brain, and it was actually the first brain to be formed. So when we were little embryos, we started as a little tube, and the nervous system that formed around our intestine was actually the first brain of our body. And in a way, we developed the second one on our head as a bit of an afterthought, which is quite a fun way of thinking about it. But it just shows how important the nerves are in our gut to the way we function. And as we were talking earlier about this connection between the two. And there's also immune cells. So 70% of our immune cells are in the gut, most of them in the large intestine, but also in the small intestine. So our immune system is here, and a huge amount of our nervous system is here.
Why? Presumably the bugs are all through the body.
They're everywhere. So they're also in your, yes, so I should point out, we're covered in bugs. So every bit of the human body has some bugs in it. The second biggest place where we have them is in our mouth, so the oral microbiome, in our saliva and in our teeth and our gums. And that's why poor hygiene, if you're not flossing properly, you double the risk of getting dementia as well, interestingly. Because there's a real link between microbes here that if they're eating plaque and other stuff that you're leaving around in your gums gets inflamed, that creates an environment where nasty microbes that love inflammation live. And for reasons we don't know, they seem to pass from your mouth into your brain and trigger inflammation in the brain, which then increase your risk of dementia.
If you're not flossing.
Yes, this is really new science showing that just how important getting the right bugs in the right place and avoiding the ones who are in the wrong place really is.
Why do we need these bugs? Why didn't evolution design us so that we could just do all this stuff without the need of these little workers, these little bugs in our bodies? It seems super weird to me that, you think of the human body as being this one organism, but actually it appears to be many millions and millions and millions of organisms.
Well, you've got a sort of human-centric view of the world, Stephen.
True,
we evolved from microbes.
We are one. We used to be one.
We used to be one. And it turns up that most of our body are remnants of microbes. Microbes obviously fuse to cause human cells. So that was the whole origin of how multicellular creatures came together. These single-celled microbes, some of them fused to do that. Others stayed as single cells. There was always this link between the single-celled guys and their multicellular ancestors, if you like. And so as we co-evolved into more complicated beings, the two were always together. And it turned out that, again, as we're formed as embryos, the gut is the first thing that, this tube is the first thing that comes out of the design system. Mm-hmm. And it's designed to have microbes in it that serve a crucial purpose in training our immune system to recognize what's harmful and what's beneficial. And it's also shown to be crucial for our brain development. But it is fascinating when we start thinking about our origins and think of it that, we essentially start as microbes, because also we don't think of our body, we've always historically thought of, God's creation, this body had nothing to do with anything else. We were the masters of the universe. And I think it's quite humbling to realize that so much of us comes from microbes. And I learned something recently that also blew me away, is that all our cells have these powerhouses in them called mitochondria. And it turns out they do much more than just supply batteries for the cell. They're fighting inflammation, they're important for gene expression, they're good for metabolism. And it turns out the origin of these things is little microbes that got trapped in our bodies. They are essentially microbes that were good at creating energy. And at some point in our distant past, we fused our multicellular microbes that were going around doing stuff. They said, we could do with some more energy. And so by chance, they fused with these energy microbes and slowly became incorporated into our bodies, so that we now have these mitochondria all over our bodies, whose ancestors are also microbes.
And we have them in every cell of our body.
Yes, we do. And they're turning out to be quite crucial as well in brain health.
If you love the Diary of a CEO brand and you watch this channel, please do me a huge favour. Become part of the 15% of the viewers on this channel that have hit the subscribe button. It helps us tremendously, and the bigger the channel gets, the bigger the guests.